Saxon's Trig, lesson 30, beginning on page 205, is about addition of vectors and overlapping triangles. Now, vectors are very helpful. They are basically angles, and their applications apply to flying, navigating in a boat, the force of two pulleys interacting on something. So it basically is when you have two different angles that are pulling on an object, and that's going to form a right triangle, and you can therefore find how long the x is, how long the y is, or you can find the hypotenuse. The force that needs to be pulling is going to be that one. And if you have two of them and you then try to put them together, so you've moved to this point with the first one, and then you skew off this way, and you end up with a right triangle here. So they're asking, what is the ultimate that this is doing when added with this one? So rather than trying to rotate fractions, triangles, and figure them out and draw them together in one picture, we decided, or mathematicians discovered, that if they took the x value and y value of both of these and then added them together, it was what they got when they did this manipulation and actually found it. So when we want to add two different vectors together, the answer that we get is called the resultant. And that's important because there is a flipped value to it. But for the moment, resultant is the answer to adding vectors. So in their first example, they're giving you 4 20 degrees and asking you to add that with 7 and negative 270. 230 degrees. Okay, there we go. Now, what you want to do then, as I just said in the example, is find the x value and the y value for each of these and add those together. Now, in this format, the polar format, I can't do that. But in the rectangular format and remember, if it's in the upside down division box, your answer should be in, what did I just say? In the rectangular format should be with I, the caret I, and the caret J, this one for the X, this one for the Y. Okay. To do that, to get these in this format then, I need to graph both to convert them over to their rectangular form. So the 20 degrees, now I have students who want to do this on their calculator and shortcut things, and that's fine if your calculator allows you to do it. But on your standardized tests, you may not be able to use your calculator for this part, or you just need to know the basics to understand how this thing works. You will want to practice at least a few of these with drawing it before you shortcut that on your calculator, if your calculator does that. So we have 20, and then we are labeling our hypotenuse of 4. 20 degrees is not a memorized, so I can't just label these parts and move on. I need to actually stop and work on the calculator to find the I and the J. So remember that when you do the cosine of 20 degrees, that's ca, that is your adjacent, so that's your x value over your hypotenuse of 4. Cosine of 20 times 4 will give you your x value. And then the sine of 20 stands for your opposite, that's your y value over your hypotenuse of 4. So again, sine of 20 times 4 will give you the answer that you want for what y equals. Now, I'm looking over here since I'm not working on my calculator. And it's, oh, here it is. 3.76 is the x, and 1.37 should be the y value. Yes, okay. So now these are those, and I'm going to go ahead and write it in its rectangular format. So this is going to be putting x first, 3.76i, and in this quadrant, that's a positive, and this is a positive, so you always check the quadrant for the signs, 1.37j. That's the answer, rectangular format for this one. Now we need to graph negative 230 degrees. So I'm going backwards this way, negative 90, negative 180, negative 270. Okay, it's between these two. So there's my 90. how much past the 180 to get to 230? It should be 50 degrees. And then my hypotenuse is 7. So we're going to do cosine of 50 degrees equals, the cosine is always the x over the hypotenuse of 7. Then the sine of 50 will be the y over the 7. Cosine of 50 times 7, sine of 50 times 7 is going to give you an x answer of 4.5, a y answer of 5.36, and my quadrant tells me x should be negative and y should be positive. Writing it underneath here, x first, so negative 4.5i plus 5.36j, and then we want to add those together because it asks for the resultant, so that's implying the addition of, and also we have the plus sign here. So now we put this together, so that's actually going to be a negative answer when I put them together on the calculator, so negative 0.74i, and then that will be a 6 or 7 point something, 6.73 with the j. Now, here's the other thing that gets a little bit frustrating with these problems. This started in polar format. We put the answer in rectangular format, but it implies if it gives it to me in polar that it wants the answer in polar, which would require another step of regraphing this and putting it back into this format. I don't ask you to do that extra step. So if I can, in my answer key, I might write both answers for homework questions. However, I'm okay with you stopping here, but if the original, especially in a standardized test, is given in polar format, you want to convert it to polar format. So just so you can see that at least one time, where would this graph? Negative this way, positive this way, so it's going to land in quadrant 2, and this is going to be labeled negative 0.74, and this one's going to be the 6.73. What information do I need to put it back into polar? I need the hypotenuse. Stop in Pythagorean theorem. So 6.73 squared plus negative 0.74 squared turns it into a positive, and then square root that answer to get the hypotenuse, and so the book tells me that's 6.77, and now I need the degree. So I have to, since I've said before, I don't like to use the new answer that I got. I want to stick with the originals. I would do the one that uses the adjacent and the opposite. So that would be tangent. Tangent of the unknown degree, I'll call it x degree, equals tangent, TOA, opposite over adjacent. So 6.73 divided by 0.74. Now on this one, I know it's negative, but it doesn't matter here. I'm going to do the adjustment. Like the calculator's going to spit out the degree, and then I'm going to say it's attached to the 180 before I fill into its answer piece. So I don't need to worry about the sign part. I just fill them in as positive numbers every time. So 6.73 divided by 0.74 on the calculator. And then I want the calculator to tell me the degree. So this is where I inverse or second or shift, whatever your calculator needs, with the word tangent so that it spits out a degree, which is 96.27. Okay. Now at this point, because it landed here in my actual answer, I would not fill in the 96.27. That is what the book did. Oh, wait a minute. Nope, sorry. Haha, fix that. They spit out 83.73. There we go. Now we're going to fix it attached to the 180. So we didn't reach the 180, so it's 180 minus 83 here, and that's where I get the 96.27 degrees, and that is the answer in polar. Like I said, I will accept it back over here in rectangular, but that's how you're going to go through a graph one more time to get it back over to polar form. Example 2 now says 2 forces where lb means pounds, 4 with 50 degrees, and -6 with 170 degrees are applied to an object. Find the equilibrant of the forces. Okay, now here's the new word. Equilibrant. So before we found the resultant, and it is just the straight up answer when you add these two together. The equilibrant is going to completely do the opposite once you get the answer. So just know that equilibrant means there's one more step of flipping it. And I'll try to show you what I mean when we get down to the end. So let's graph our 50 degrees and our hypotenuse of 4. So that I know that my x answer is positive, my y answer is positive. We're going to do on the calculator, sine of 50 equals the y over 4. Cosine of 50 is the adjacent, so x over 4. So our y will equal something, our x will equal something. They're both positive, and that should be 2.57 and 3.06. Do the same thing for 170 degrees, 0, 90, 180. Didn't quite reach 180. I've got a gap of 10 then between 170 and 180 because that's traveling 170 degrees. Hypotenuse is -6. Uh-oh, have a problem. So before I finish this answer, I realize that I can't be using a negative with my sine and cosine words. So I'm going to have to flip this to its opposite corner to change the hypotenuse from being negative to being positive, but the degree is still 10 degrees. Now I know that my x answer is going to be positive and my y answer is going to be negative. You're going to do sine of 10, that's the y over the 6. The cosine of 10 is the x over the 6. And they're telling you that x and y, let's see, the x 5.91 and the y 1.04. All right, let's put those in their rectangular formats. So this one is 3.06i plus 2.57j, and then we are combining that with x was positive, 5.91i. This was negative, so minus 1.04j. And we put them together, the 3 and the 5 should make an 8 point something. So 8.72i. 2 minus 1, it's going to be either 1 or a decimal of some sort. Wait, I may have just used... Nope, I wrote this wrong. 8.48, and wait a second. Did I flip these when I wrote them? I did. This, oh goodness gracious, 2.57, oopsies, and this should have been 3.06. Okay, hopefully that didn't throw you off. Make sure I put that in the right order. Okay, 2 and 5. I got the 8 still because this was enough in the decimal to bump it up. So 8.48i, yes. And then a 3 minus 1, I would expect to see a 2 point something, so 2.02j. All right, hopefully that's not throwing you off. Okay, so now we know what our answer is in rectangular format for the resultant. I've not dealt with equilibrant. All right, so now if I put it in, I can do this two ways. I can go ahead and convert it to polar and then fix it, or I can, and I said equilibrant means you're changing these, you're changing the sign on both. So at this point, I would probably deal with it in change it to equilibrant, which means I'm actually doing negative 8.48i plus 2.02j. That's the equilibrant where I've changed both the signs. And then I would accept the answer in here, but because it started out in polar, they want to see it in polar. So you would do negative and positive, so it's quadrant 2, 8.48, 2.02. Again, Pythagorean theorem to find the hypotenuse, which ends up being 8.72. I don't like the way they wrote their answer. And then, again, I would do tangent, TOA, opposite over adjacent. So 2.02 divided by 8.48, second inverse or shift tangent, depending on how your calculator wants it. And that should give you the degree, which they're saying is 13.4. And I'm saying because I'm in quadrant 2, I want to see 180 minus that filled in here, but they filled in 13.4 degrees, and then because it was a word problem that started out saying it was pounds, they put their answer in pounds before they boxed it. And okay, I don't want this to throw you. They changed the sign on this 8.72 because they didn't, this is the other reason why they kept it at 13.4. They flipped it again, making their hypotenuse negative, and they're doing that because they're saying we're finding the equilibrant, and this is the graph that we did when we changed the signs. So we're trying to undo that fixing to put it back, and so then they're getting their answer. You get somewhere close in the ballpark, and we're not going to worry about the differences with the positives and the negatives and the rest of it. I want you to understand it enough to do well on a standardized test, of course. I don't want it to throw you, but I think you have enough of an understanding going through the process. If it starts in polar, you want it in polar, I'm going to accept it in this. Resultant is the straight up answer. Equilibrant is the answer where I change the signs, and then how far you take it in its final graph is a little bit of wiggle room. Example 3. What vector force must be added to 20, 30 degrees plus an unknown to obtain a resultant, so I know I'm not worrying about equilibrium with changing signs and all the rest of the craziness, of 25, 0 degrees. So we are going to do the same thing we did before in graphing and finding the i's and j's, except that we're going to do an algebra step of actually solving for this gap by minusing this one. So our 30 degrees, oh, this one I can do on the calculator, or I can do it a different way, because 30, 60, 90 is one of our special memorized triangles. Opposite the 30 is a 1, opposite the 60 is a √3, and the hypotenuse is 2, if I label it. But what was the provided hypotenuse? 20. So how did I change from 2 to make it 20? Well, I multiplied by 10. So if I do that with each of these, then I know this side is 10, and multiply by 10, that's going to be 10 √3. So without going through sine and cosine on my calculator, I can immediately take this to 10 √3i plus 10j for the answer here. And I know that we are adding this to the unknown to get, now let's work out this one. 0 degrees is on this line, quadrantal triangle then, because it doesn't really exist. I am traveling over, but not up, and I'm gonna match. And there, oh, my hypotenuse, however, is 25. So when I change this to 25, I need to write this one as 25. The 0 multiplied by 25 doesn't change it, it's still 0. So I know that this is 25i plus 0j. And because I'm solving for this blank, I'm actually minusing 10 √3i minus the 10j. And that's going to give us, ooh, that's messy. Add a 2, yes. Making sure I didn't have any boo-boos in here. Oh, Yeah. Because I did it with the root 3 and I didn't do sine and cosine, they took it to a decimal. At this point, just change this to its decimal format and then do 25 minus that, and you should be getting 7.68i, and 0 combined with this negative 10 is going to be negative 10j. Yeah, that matches what they have. Okay, then this is the rectangular format that I would accept as the resultant force answer in here, because they had it in polar, they want it converted. If we convert that, then that is positive and negative, quadrant 4, 7.68, 10. Pythagorean theorem to find the hypotenuse, that should give you 12.61. Then do inverse tangent, so 10 divided by 7.68, second tangent, should give you a degree of 52.48. Now, I can write the answer as positive 360 minus 52.48 and write that in there, or I can just go the opposite direction and write this as negative 52.48 degrees. Either way, I'm putting it in quadrant 4. They did it this way. And they also said that they would accept this answer, but this was in force newtons, so I do need to have newtons with that answer as its label, so that many newtons would be sufficient. Part B now changes gears to some more proofs with overlapping triangles. Example 4. Given, so we know we're going to have our statement and our reason, and I probably should draw their picture. Extend a little bit more. Close enough. All right, so this is A, B, C, and D, and that's all they labeled. Given, so obviously I'm going to write out whatever they gave me here. My reason is it's given. Okay, so I want to label that in the picture. What did they give me? AB is congruent to DC, okay, and BD, that's this line, is the same as CA, which is this line this direction. I'm kind of putting it tight in the middle so that I know it's not just this little top half. I'm trying to give myself that visual that it's this long line and this long line. So I have two given parts to a triangle. What do they want me to prove? Write a 2-column proof to show that triangle ABD, so this bottom triangle is congruent to DCA, which is this bottom triangle. All right, so I got 2 parts already in my given. I need a third because these are not right triangles. I can't use 2 pieces only. Do I have any angle that is shared? No. Do I have any side that is shared? Yes. AD is the same in both of those triangles. So segment AD is congruent to segment AD. Why? It's identity. Then I have 3 parts, so the triangles will be congruent. Oh yeah, and again, I use identity, they say reflexive, either way. So triangle, I'm gonna put it in the order they give it, ABD is congruent to triangle DCA. And what was my reason? Well, that was side, side, side. Didn't matter which way I started. And that has proven it. Oh, that was an easy one. All right, example 5. Now my triangles are overlapping. Oh, I did not make that straight enough. Hopefully that doesn't throw us off. This connected somewhere in here. This side connected somewhere on this one. Close enough. All right, so we have P, X, Q, Y, and R. Oh, you know what? Let's just break our line there, statement and reason. Here we go again. We know that this is going to be given. All right, what did they give me? PQ, that's this line, again, I'm going to go tight, is congruent to RQ. just a second. PQ. Yes, RQ. Okay, all right, here we go. Big line, got it. And QY, little line, oh boy, is congruent to QX, little line. So what I might do to avoid confusion maybe is move these down. So the big line and these little lines is what we're trying to indicate. Where are we headed? Triangle PQY, upper triangle, is congruent to RQX, so this triangle. Alrighty, we have a side, and so the long side and the little side. We have two sides in our given. What can we say is shared in both? Ooh, this angle. So we need to say that. Angle PQR is congruent to angle RQP. Y, reflexive or identity, however you wish to say it. We now have three parts. So the triangle, and again, I want to write it in their order, PQY is congruent to triangle RQX. What's my reason for that? Side, the long one, angle here, little. So side, angle, side, and that's the proof that we wanted. Example 6, last one. Okay, see if I can draw this picture slightly better. Okay, and then it's connecting and connecting. We have X, Y, V, U, and Z. All right, statement and reason. We know our first one's going to be whatever's given. Marking the givens on the diagram. X, Z, big long line. I'll do it tight there. Goes with YZ, do it tight there. XV, that's this line. Okay, we'll go tight there. Oh no, it doesn't say matches with, says is perpendicular, so I cannot mark anything there. XV is perpendicular to YZ. Okay, I can mark then that this is 90, implying the other side is 90. Also, YU is perpendicular to XZ. So again, I'm going to mark my 90 degrees on the other side of where my little tick mark was. All right, we've done that. I now know that the very next thing, since I marked them as 90s, that I really want to state that so I don't get it confused. So angle XUY is 90 degrees. Also, angle YVX is 90 degrees. And how did I know that? I marked it because it said definition of perpendicular. You can either use the symbol or write out perpendicular. I'm all for shortcuts. All right, so now what we put in there, I definitely marked. That was all the givens. Where were we headed? Write a two-column proof to prove that XV, this whole big line matches with YU, this whole big line. Okay, so in this big line was given, this big line was given. So and because this is where my 90 degrees are, so I'm using this triangle. I really should have stated this one because this is the triangle I'm going to use. I would fix that and say instead of XUY, oh wait, can I do the bottom triangles? No, because they don't use the big long line. I really should say this one, ZUY, ZUY. And for this side, it would be this one, so that would be ZVX. Now it's fixed. Okay, I have then the long line and the 90 degrees. So I've got a side and an angle, but they're opposite each other. I do have something shared in both triangles though, that's angle Z. So angle Z is congruent to angle Z. I would use identity, they would say reflexive. Does that give me 3 in a row? Side, angle, angle. It does. Great. So then I can say that triangle, as long as I'm marking the big ones, it's good. XV, yes, XVZ is congruent to triangle YZU. Why? Because we had a, and again, that was angle, angle, side. Angle, angle, side. Or SAA, either way. And then it wanted the other two parts of that triangle, so we do need a final step in restating what they wanted. XV is congruent to YU, and we haven't used it in a while, but corresponding parts of congruent triangles are congruent. CPCTC.